Our project is to detect credit default risk. We have 6 people in our team. So I'll briefly talk about the overview of our project. Credit or default risk is the probability that companies or individuals will be unable to make the required payments on their debt obligations. Lenders are exposed to default risk on every extension of credit. Many people struggle to get loans due to insufficient or non-existent credit histories. And unfortunately, this population is often taken advantage of by untrustworthy lenders. In this project, we will use a variety of alternative data, including telecall and transactional information, to predict the underserved population's repayment ability. Our objective of the project is to predict a client's loan repayment ability who has insufficient credit history based on other personal data and information. Our vision for success is to be able to use insights to make better decisions on whether or not to lend a loan to applicants with a high accuracy of their default probability. And after comparing different machine learning models, our final deliverable would be a finalized model with at least 75% accuracy to predict the likelihood of a client failing to repay the loan.
Generally, we will build a binary classifier. Our input includes 6 cans of different data, including demographic data, previous credit data, the previous application data, and payment status information, and so on. And our output will be whether or not a client could repay a loan.
So the technical components of our project mainly consist of 4 parts. They are data collection, data exploratory analysis, feature engineering, and the construction of machine learning model to make prediction. Among all those 4 parts, data collection is thought to be the easiest part because we can get access to the data set provided by the company called Home Credit, which includes the personal information and credit history of more than 300,000 loan clients. Next, the difficulty of data exploratory analysis and prediction is moderate because it is closely related to what we have learned in classes. For example, examining mixing values, finding correlation between label and the features in the data exploratory analysis, deploying different machine learning models in the prediction part. We are pretty confident to apply those data processing techniques and machine learning algorithm we have learned in this project. Feature engineering, however, is considered to be the most difficult part because none of us are really familiar with this topic, and it could be energy and time consuming to extract the useful and highly correlated features for further machine training.
There are some important metrics to evaluate the classification models. Accuracy measures the ratio of correct predictions to the total number of cases evaluated. However, it cannot perform well for most imbalanced classes. So, we plan to choose F-score and AUC for our evaluation. We know that there are an inverse relationship between precision and recall. While the F-score, the harmonic average of precision and recall, can help us find a balance between them. AUC means the area under the ROC curve, which plots the true positive rate to false positive rate at different classification thresholds. Using the AUC matrix, we can quickly compare multiple learning models. When comparing 2 models, the one with the higher AUC will be the better one regardless of the threshold settings.
Here is the basic architecture we plan for this project. Most input data will be in CSV format from our data source, which is Kaggle. We should also input additional data and adjust the hyperparameters by hand. The tech stack will mainly be what we're learning from this course. Using Python with Jupyter Notebook and various libraries such as Pandas and scikit-learn. Hardware-wise, our own laptops should be sufficient for this project. The output will be in the form of 0 and 1s results for each loan applicant. 0, 1 for default or not default. We're also considering outputting comprehensive report and visualizations on the data if it's possible. This will, of course, be an iterative process, and the output will help us make informed improvement on our whole project.
For the timeline of our dataset, we plan to spend our first week on exploring the data. Since there are over 30,000 rows of loan records and hundreds of features, we need some time to dig into the data, looking for a proper way to deal with them. Once we have a better understanding of our data, we'll start a process of feature engineering beginning on week 2. This process will take the majority of our time because there are so many categorical features that need to be transformed. For the third week, we might continue working on those features. Once it's done, we'll begin the trial of different machine learning models and then evaluate them. Everything after that are still undecided. It all depends on our progress.